Hey guys, welcome back. So, we got this hoop, let me show you. Looking good. It's actually welded to the plates now, and we set it in the car and just kind of tacked it in lightly. And obviously we took the top off, make it a little easier to work on. So as far as our list goes, we're at this point. You will note, I skipped a few steps, for better or worse. We ended up about half a degree off, and we were about 0.2 when we started, so it moved about 0.3 degrees through all the welding process. Luckily, it moved in a favorable direction, so that we're not at 90. We're tilted this way a little bit, which is preferable because it moves it, away from the driver a little bit further back. I can push the seat back slightly more. So that's kind of, if it was going to be off in one way or the other, that's the way I would have wanted it. So that was just luck, but that worked out. So one thing we did, one of our last steps is to tack weld these plates so they don't move, and we just put one tack weld on each side. So this is actually, I don't know if that shows up, it's kind of flimsy because it's not welded to the car, it's just tacked. But that's all we need for now. So let's get to the meat and potatoes of the next step. So if you guys remember, the next one is the seat. So first one is tap the brackets for 1/2" threads. We already did that. Now we're on the next step, which is putting the seat where it goes. So let me show you guys. I don't know if this is going to work, but this is what we're trying. So here's our brackets. These are the ones that we designed, and we had these laser cut, and that actually worked out great. There's a couple things I could have done better. So these were laser cut, and the reason you can tell, notice around the edges there's a discoloration. I don't know how good that shows up on camera, but it's that's the laser. Literally, yeah, there you go. There's a real good color difference. That's the heat. So upside or downside, depending how you look at it, heat treats that edge. This metal is actually a lot harder than what's here from the heat. And I accidentally, when I had them do this hole, I wanted this hole to be tap drill size so I could run a tap in and thread it. They did not thread this part, I did. But what I should have done is have them cut the hole a little undersize and then drill it with a correct size drill to open it up to spec. One, the drill gives you better tolerance, but two, when you run a drill in here, you got to drill that super hard steel out, and then when you run your tap in, your tap's just going through regular steel, not through this heat treated steel. I forgot to do that. I was just in a hurry. So they ended up making them tap drill size. So here's the tap drill bit, and when I tried to check, this just went right through the hole. So all I could do is really just run it back and forth a little, try to knock a little bit of the hardness out, and then after that I ran a tap in. Now it did work, but let me show you guys one of the keys to success when you're running a tap. I guess there's a few, but if you've only got so much to work with, let me tell you the most important step. Have a good tap and have the right tap, which really just comes down to that, I guess. But so this tap I bought off of I think it's McMaster-Carr. So if you guys have never used McMaster-Carr, they have all kinds of tools and equipment. Decent pricing, quick shipping, very easy website to use to order stuff, better than Amazon in some ways. But they sell quality stuff. They don't sell junk. That's the great thing about McMaster-Carr. They don't sell junk. If you buy a drill bit, you buy a tap, it will be a good one. They don't sell junk. That's so important. Amazon does sell junk. So I got this drill bit and the tap off of there, and this is a good tap. So this is like a taper tap. So if you notice, I don't know. I'm not sure my audience, how many people understand this, but if you look at the threads on the tap, sorry, the focus just, oh, come on, tap. Anyway, notice how down here there's basically nothing, and you see the threads slowly kind of come into existence, and then eventually, way over here, you can see full threads, but back here, not so much. And what happens is, down here, this is the size of the hole, and each time you're going, you're taking a little chip, and eventually you keep cutting until you cut the entire profile. That's the idea of this. And then this happens to be a 4-flute tap, which is fine. I would have preferred a 2-flute or a 3-flute, but this worked okay. But this is a good tap. It's high-speed steel, so this is, even if it's Chinese, which I don't know if this is Chinese, but this is good. This is a good quality tap. You can kind of tell by looking at taps when you look at them. This thing is sharp, and it's got a pretty hard steel, and that's real important. So that ended up being extremely important since this was, laser cut, and I couldn't drill out the hard steel, so I had to run this tap into a pretty hard steel, and it worked. Didn't really have any issues. It was tight, but it did it. Another big thing is to use tapping fluid. This is some pretty good stuff. I love this one. But yeah, I just power tapped them. So I just put the tap in the drill, tighten the crap out of the chuck. I actually, this shank was slipping, so I took some brake cleaner, and I cleaned the shank of this, and I sprayed some of this brake cleaner on a rag, and I actually cleaned out the ID of the chuck. I've never done that in my whole life, but I reached in there and wiped all the oil out, because after chucking who knows how many things, it was pretty dirty. So I cleaned that, and that helped it to not slip on this surface. But yeah, we just power tapped them, and that's how we put the threads in these things. And it actually turned out nice. I'm not sure. Yeah, there you go. Kind of shows up. But threads look pretty good. We don't know if that's going to be the only thing holding the seat in yet. That's kind of like a decision we'll make down the road. But for now, we're going to have 4 of these brackets, at least 4, maybe 6, holding the seat. And these are all 1/4 inch thick steel, and they're going down on 1/8 inch steel plates. Not going to be exactly like what you see. This is just kind of for mock-up. Nonetheless, that's our brackets. Let's talk about what we're doing. So when you think about a race car and your seat, right? So when you're talking about weight in a race car, you want the weight, generally speaking, as low as possible. That's a pretty common one. And most of the time you want to push weight to the back of the car, generally. So but then there's other constraints as well. But the keep it, like for example, for driver, I want the seat in wherever I'm the most comfortable. That's actually really important. But then getting the seat as low as possible is almost a universal. There's really hardly any downside to that. So what we're going to do, these are 1/8 inch plates, which this one is going to be welded to the floor the way it is. This one, same thing. These others around here, these could get modified because there's not rules regulating that so much for the seat brackets. And then this is 1/4 inch, quarter, and quarter. And what we're going to do, we're going to set the seat up here, and we're going to try to use these spacers to keep it 1/4 of an inch off of this floor, which means it'll be about 1/8 inch above these surfaces. Now the reason we're doing that is in the center of the seat, we're going to have to run seat belts and tie them into something, which right behind this, like right in that area of the seat, is this plate. And this plate's 1/8 of an inch tall. We may end up running our lap bolts right into this. I haven't ruled that out. So basically you would run the lap to here, drill a hole through this, run a bolt through this. So basically you'd have like a bolt, your seatbelt steel, go through this steel, go through the floor, and then on the back side, go get a big beefy piece of steel and, you know, bolt that on the bottom. And I mean, it'll just be super strong. So we may use that. But if we don't, we'll be using something here with the same idea to put some steel and bolt underneath or something, or weld something. We'll figure it out. But regardless, you need a little bit of room. So that's what this 1/4 inch plate's for. We were previously using like plywood and some other stuff. We had it raised up more than that. But the more I think about it, I'm like, you know, that's not helping. I'd rather the seat be as low as possible, because that makes the car faster, helps with weight transfer. And in a small way, it's actually going to help when we do these rocker bars. The lower that seat is, helps me, and then moving the seat that way as far as possible. So those two things we're going to be paying critical attention to. So with that said, we're about to take the seat, throw it in the car, kind of move it around, see where it, get it adjusted, and then hopefully we can get it to kind of balance right on that 1/4 inch plate, and then we can start positioning our tabs where they're going to go and start getting those ready. So I'll bring you guys back in a second. Okay, so this is like a approximate position of where the seat's going to go. One thing we did, so the seat wants to kind of fall backwards, so I took this tube I just happened to have laying around that was coped and just grabbed a clamp and clamped it, and that gave it some friction, and I can rotate that, and it's pushing on the seat obviously. So that lets me kind of adjust the seat and make sure that, you know, I want it in front of the hoop, as you can see. So that kind of helped keep that position. We've got it sitting on these plates. What's critical is this area down here. So we actually created this little pocket, and from looking at it, man, I didn't realize it at the time, but shifting that even more would have been beneficial. But it would really suck to redo all that. But let me try to get a better camera view. So way down in here, it's hard to get, oh, that kind of works. Yeah, so there's a little bit of room down here. I mean, I can barely get my fingers in here. There's not a lot of room, but there's some. I need to get a mounting tab pretty much right in the center of the screen. And then back here, same thing, I need another tab there. So there is enough room. I'm gonna take and drop one of these in here to show you. Hopefully nothing moves. Yeah. Yeah, so there you go. So that tab fits, but just barely. Let's see if I can find a short one. I think I got my foot on it. There we go. Sorry. Let's see. Well, it's a little too tall for the back. We had a space tire when we did these. I may have to adjust those. Yeah, I had the seat space when I designed those tabs. So we may cut them shorter. Luckily, it's easier to make things shorter. But that tab's going to go further back. It's just going to have to be shortened if we keep the seat this low. But that's kind of how that's going to go. Let's look at this side. We're going to have the same problem. These are going to be a little bit too tall. Something like this. So essentially these things would be welded to those plates, and then I have some bolts that are going to attach the seat to these brackets. So these are 1/2-inch threads. They're pretty beefy. And let me show you the bolts I bought. I bought these. These are kind of pricey. But these are 1/2-inch diameters, a 1/2-13. But they're button head, Allen socket head, Allen button head, whatever. But that way you don't have a bolt poking you as much in the seat, but you got some really, really beefy threads. And I got a bunch of these, so if I decide to use a lot, it's not going to be a problem. This is the drive, it's a 5/16 drive to even spin them. So pretty beefy stuff. So we should be good on that. And once we get those put in, we may actually add some additional brackets, like on the bottom of the seat. Per the rules, the seat brackets are supposed to be on the bottom, but everybody puts them on the sides. You can kind of see why, because you can actually see the sides and get to it and build it. But once I get these, I may, after the fact, build some bottom ones and tie those in, because it wouldn't be that hard to do. So we'll see. But we're definitely doing these for starters. So we're going to do something like that. I'm going to keep working on this. I'll bring you guys back when we make some more progress. But yeah, it's looking like we got to think about our seat. Make sure, one thing I might do is try to take the lap belts and try to fish them under the seat and just make sure that that 1/4-inch assumption of mine is actually valid, because that's really the only reason we're doing that. So it's like, I think it's this strap. I mean, it looks like it's fine, but we'll make sure that's really going to work. But if it looks like it's going to work, I think we're going to stick with this 1/4-inch gap, and then we'll proceed with getting our brackets. And our goal will be, when we figure out where the brackets are going to go, we're probably going to like tape them to the seat or something, or mark them with a Sharpie, something like that. And then we're going to take it out of the car, transfer the center of the bracket, like where the bolt goes, to the seat, and then drill a hole through the seat. And at that point, you can just run a bolt through the seat right into the bracket and bolt the seat to the brackets. Once that's complete, this is probably obvious, but once that's complete, we can take all those spacers out in the middle and just set the seat where these brackets are physically bolted to the seat, set it down onto the plates, and at that point there will be a gap under the seat. You could actually sit in it, and that would be, you can see how that works. And then we can check our seat belts, make sure that's going to work, and if it all looks good, we can start tack welding the brackets to the plates, or the plates to the car, all that kind of stuff, and start finishing that up. So anyway, until next time, y'all take it easy.